This is the Wikipedia page for flatulence, part 1 of 2. Flatus, intestinal gas, is mostly produced as a byproduct of bacterial fermentation in the gastrointestinal tract. You're listening to the podcast where we read Wikipedia articles every day and provide commentary. If you like what you hear, please subscribe and consider donating at patreon.com/WikiListen podcast so we can continue to create this show. You can find us on social media at WikiListen and at WikiListen.com. Welcome to WikiListen. I'm Victor Varnado, KSN.
And I'm Rachel Teichman, LMSW.
Right on. Let's get this potty farted. Flatulence is defined in the medical literature as flatus expelled through the anus, or the quality or state of being flatulent, which is defined in turn as marked by or affected with gases generated in the intestine or stomach, likely to cause digestive flatulence. The root of these words is from the Latin flatus, a blowing, a breaking wind. Flatus is also the medical word for gas generated in the stomach or bowels. Despite these standard definitions, a proportion of intestinal gas may be swallowed environmental air, and hence flatus is not totally generated in the stomach or bowels. The scientific study of this area of medicine is termed flatology.
Flatus is brought to the rectum and pressurized by muscles in the intestines. It is normal to pass flatus, though volume and frequency vary greatly among individuals. It is also normal for intestinal gas to have a feculent odor, which may be intense. The noise commonly associated with flatulence, blowing a raspberry, is produced by the anus and buttocks, which act together in a manner similar to that of an embouchure. Both the sound and odor are sources of embarrassment, annoyance, or amusement. See flatulence humor.
Blowing a raspberry. Nice.
Nice.
There are several general symptoms related to intestinal gas, pain, bloating, and abdominal distension, excessive flatus volume, excessive flatus odor, and gas incontinence. Furthermore, eructation, an act or instance of belching, colloquially known as burping, is sometimes included under the topic of flatulence. When excessive or malodorous flatus can be a sign of a health disorder, such as irritable bowel syndrome, celiac disease, or lactose intolerance.
Terminology. Non-medical definitions of the term include the uncomfortable condition of having gas in the stomach and bowels, or a state of excessive gas in the alimentary canal. These definitions highlight that many people consider bloating, abdominal distension, or increased volume of intestinal gas to be synonymous with the term flatulence, although this is technically inaccurate.
Colloquially, flatulence may be referred to as farting, pumping, trumping, blowing off, pooting, passing gas, breaking wind, backfiring, or simply, in American English, gas, or British English, wind. Derived terms include vaginal flatulence, otherwise known as
Signs and symptoms. Generally speaking, there are 4 different types of complaints that relate to intestinal gas, which may present individually or in combination.
bloating and pain. Patients may complain of bloating as abdominal distension, discomfort, and pain from trapped wind in the past. Functional bowel disorders such as irritable bowel syndrome that produced symptoms of bloating were attributed to increased production of intestinal gas.
However, 3 significant pieces of evidence refute this theory. First, in normal subjects, even very high rates of gas infusion into the small intestines, 30 milliliters per min, is tolerated without complaints of pain or bloating and harmlessly passed as flatus per rectum. Secondly, studies aiming to quantify the total volume of gas produced by patients with irritable bowel syndrome, some including gas emitted from the mouth by eructation, have consistently failed to demonstrate increased volumes compared to healthy subjects. The proportion of hydrogen produced may be increased in some patients with irritable bowel syndrome, but this does not affect the total volume. Thirdly, the volume of flatus produced by patients with irritable bowel syndrome who have pain and abdominal distension would be tolerated in normal subjects without any complaints of pain.
Patients who complain of bloating frequently can be shown to have objective increases in abdominal girth, often increased throughout the day and then resolving during sleep. The increase in girth combined with the fact that the total volume of flatus is not increased led to studies aiming to image the distribution of intestinal gas in patients with bloating. They found that gas was not distributed normally in these patients. There was segmental gas pooling and focal distension. In conclusion, abdominal distension, pain, and bloating symptoms are the result of abdominal intestinal gas dynamics rather than increased flatus production.
Excessive volume. As mentioned above, the normal range of volumes of flatus in normal individuals varies hugely, 476 to 1,491 milliliters per 24 hours. All intestinal gas is either swallowed environmental air, present intrinsically in food and beverages, or the result of gut fermentation.
Swallowing small amounts of air occurs while eating and drinking. This is emitted from the mouth by eructation, burping, and is normal. Excessive swallowing of environmental air is called aerophagia and has been shown in a few case reports to be responsible for increased flatus volume. This is, however, considered a rare cause of increased flatus volume. Gases contained in food and beverages are likewise emitted largely through eructation, e.g., carbonated beverages.
Endogenously produced intestinal gases make up 74% of flatus in normal subjects. The volume of gas produced is partially dependent upon the composition of the intestinal microbiota, which is normally very resistant to change, but is also very different in different individuals. Some patients are predisposed to increased endogenous gas production by virtue of their gut microbiota composition. The greatest concentration of gut bacteria is in the colon, while the small intestine is normally nearly sterile. Fermentation occurs when unabsorbed food residues arrive in the colon.
Therefore, even more than the composition of the microbiota, diet is the primary factor that dictates the volume of a flatus produced. Diets that aim to reduce the amount of undigested fermentable food residues arriving in the colon have been shown to significantly reduce the volume of flatus produced. Again, increased volume of intestinal gas will not cause bloating and pain in normal subjects. Abnormal intestinal gas dynamics will create pain, distension, and bloating, regardless of whether there is high or low total flatus volume.
Odor.
Yeah.
Although flatus possesses an odor, this may be abnormally increased in some patients and cause social distress to the patient. Increased odor of flatus presents a distinct clinical issue from other complaints related to intestinal gas. Some patients may exhibit oversensitivity to bad flatus odor, and in extreme forms, olfactory reference syndrome may be diagnosed. Recent informal research found a correlation between flatus odor and both loudness and humidity content.
Incontinence of flatus. Gas incontinence could be defined as loss of voluntary control over the passage of flatus. It is a recognized subtype of fecal incontinence and is usually related to minor disruptions of the continence mechanisms. Some consider gas incontinence to be the first, sometimes only, symptom of fecal incontinence.
Cause. Intestinal gas is composed of varying quantities of exogenous sources and endogenous sources. The exogenous gases are swallowed, aerophagia, when eating or drinking, or increased swallowing during times of excessive salivation, as might occur when nauseated or as the result of gastroesophageal reflux disease. The endogenous gases are produced either as a byproduct of digesting certain types of food or of incomplete digestion, as is the case during Steatorrhea. Anything that causes food to be incompletely digested by the stomach or small intestine may cause flatulence when the materials arrive in the large intestine due to fermentation by yeast or prokaryotes, normally or abnormally present in the gastrointestinal tract.
Flatulence-producing foods are typically high in certain polysaccharides, especially oligosaccharides such as inulin. Those foods include beans, lentils, dairy products, onions, garlic, spring onions, leeks, turnips, swedes, radishes, sweet potatoes, cashews, Jerusalem artichokes, oats, wheat, and yeast in breads, cauliflower, broccoli, cabbage, Brussels sprouts, and other cruciferous vegetables that belong to the genus Brassica are commonly reputed to not only increase flatulence, but to increase the pungency of the flatus.
In beans, endogenous gases seem to arise from complex oligosaccharides, carbohydrates, that are particularly resistant to digestion by mammals, but are readily digestible by gut flora, microorganisms, methane-producing archaea, Methenbrevibacter, Smithii, that inhabit the digestive tract. These oligosaccharides pass through the upper intestine largely unchanged, and when they reach the lower intestine, bacteria feed on them, producing copious amounts of flatus.
When excessive or malodorous flatus can be a sign of health disorder such as irritable bowel syndrome, celiac disease, non-celiac gluten sensitivity, or lactose intolerance, it can also be caused by certain medicines such as ibuprofen, laxatives, antifungal medicines, or statins. Some infections, such as giardiasis, are also associated with flatulence.
Interest in the causes of flatulence was spurred by high-altitude flight and human spaceflight, the low atmospheric pressure, confined conditions, and stresses peculiar to those endeavors were cause for concern. In the field of mountaineering, the phenomenon of high-altitude flatus expulsion was first recorded over 200 years ago.
Mechanism: production, composition, and odor. Flatus, intestinal gas, is mostly produced as a byproduct of bacterial fermentation in the gastrointestinal tract, especially the colon. There are reports of aerophagia, excessive air swallowing, causing excessive intestinal gas, but this is considered rare.
Over 99% of the volume of flatus is composed of odorless gases. These include oxygen, nitrogen, carbon dioxide, hydrogen, and methane. Nitrogen is not produced in the gut, but a component of environmental air. Patients who have excessive intestinal gas that is mostly composed of nitrogen have aerophagia. Hydrogen, carbon dioxide, and methane are all produced in the gut and contribute 74% of the volume of flatus in normal subjects. Methane and hydrogen are flammable, and so flatus can be ignited if it contains adequate amounts of these components.
Not all humans produce flatus that contains methane. For example, in one study of the feces of 9 adults, only 5 of the sampled contained archaea capable of producing methane. The prevalence of methane over hydrogen in human flatus may correlate with obesity, constipation, and irritable bowel syndrome, as archaea that oxidize hydrogen into methane promote the metabolism's ability to absorb fatty acids from food.
The remaining trace, less than 1% volume, compounds contribute to the odor of flatus. Historically, compounds such as indole, scatol, ammonia, and short-chain fatty acids were thought to cause the odor of flatus. More recent evidence proves that the major contribution to the odor of flatus comes from a combination of volatile sulfur compounds. Hydrogen sulfide, methyl mercaptan, also known as dimethyl sulfide, dimethyl disulfide, and dimethyl trisulfide are present in flatus. The benzopyrrole volatiles indole and scatol have an odor of mothballs and therefore probably do not contribute greatly to the characteristic odor of flatus.
In one study, Hydrogen sulfide concentration was shown to correlate convincingly with perceived bad odor of Flatus, followed by methyl mercaptan and dimethyl sulfide. This is supported by the fact that hydrogen sulfide may be the most abundant volatile sulfur compound present. These results were generated from subjects who were eating a diet high in pinto beans to stimulate Flatus production.
Others report that methyl mercaptan was the greatest contributor to the odor of Flatus in patients not under any specific dietary alterations. It has now been demonstrated that methyl mercaptan, dimethyl sulfide, and hydrogen sulfide, described as decomposing vegetables, unpleasantly sweet/wild radish, and rotten eggs, respectively, are all present in human Flatus in concentrations above their smell perception thresholds.
It is recognized that increased dietary sulfur-containing amino acids significantly increase the odor of Flatus. It is therefore likely that the odor of Flatus is created by a combination of volatile sulfur compounds with minimal contribution from non-sulfur volatiles. This odor can also be caused by the presence of large numbers of microflora, bacteria, or the presence of feces in the rectum. Diets high in protein, especially sulfur-containing amino acids, have been demonstrated to significantly increase the odor of Flatus.
Volume and intestinal gas dynamics. Normal Flatus volume is 476 to 1,491 milliliters per 24 hours. This variability between individuals is greatly dependent upon diet. Similarly, the number of Flatus episodes per day is variable. The normal range is given as between 8 and 20 per day. The volume of Flatus associated with each flatulence event again varies, 5 to 375 milliliters. The volume of the first flatulence upon waking in the morning is significantly larger than those during the day. This may be due to buildup of intestinal gas in the colon during sleep, the peak in peristaltic activity in the first few hours after waking, or the strong prokinetic effect of rectal distension on the rate of transit of intestinal gas. It is now known that gas is moved along the gut independently of solids and liquids, and this transit is more efficient in the erect position compared to when supine. It is thought that large volumes of intestinal gas present low resistance and can be propelled by subtle changes in gut tone, capacitance, and proximal contraction and distal relaxation. This process is thought not to affect solid and liquid intraluminal contents.
Researchers investigating the role of sensory nerve endings in the anal canal did not find them to be essential for retaining fluids in the anus, and instead speculate that their role may be to distinguish between Flatus and feces, thereby helping detect a need to defecate or to signal the end of defecation.
The sound varies depending on the tightness of the sphincter muscle and velocity of the gas being propelled, as well as other factors such as water and body fat. The auditory pitch sound of the flatulence outburst can also be affected by the anal embouchure. Among humans, flatulence occasionally happens accidentally, such as incidentally to coughing or sneezing or during orgasm. On other occasions, flatulence can be voluntarily elicited by tensing the rectum or bearing down on stomach or bowel muscles and subsequently relaxing the anal sphincter, resulting in the expulsion of Flatus.
I like the list of foods for one.
Yeah, me too. That was my favorite part.
This has been the Wikipedia page for flatulence, part 1 of 2. Thanks for listening to WikiListen. To support the show, go to patreon.com/WikiListenPodcast and find us on social media at WikiListen and